So we're going to do heat treatment of this blade this morning. A fairly simple process. What you do is you take a blade, and this happens to be one I prepared earlier, and it's coated in a goo that you can see. Now this is ATP 641. What it is an anti-scale compound. So because this is a carbon blade, so it's tool steel, 01 tool steel, it's obviously got a high amount of carbon in it. Now I'm going to be heat treating it in my little kiln here, and it's going to be heat treated in an oxygen rich environment, which means essentially I don't have a vacuum going on it. Now the oxygen in the air will react with the carbon in the steel and pull some of that carbon out of the steel, forming a scale on the outside of the blade. Now that's not in itself a bad thing. I can get rid of it by basically just sanding it off, but the problem is that it will rob carbon from the steel. Now carbon and iron is what makes steel, and carbon is what makes the steel hard. So more carbon taken away from the steel, the less hard the blade potential will be. Now this is going to be absolutely minimum normally anyway, but it doesn't hurt to make it even less than normal. So what we do, open up the kiln, put the blade inside. Now you'll notice there's also some dirty old chunks of steel in there. They go in the oil, and their job is simply to heat the oil up before I put the steel knife blade into the oil. So down here I've got a big old tank of oil that will get red hot, and I'll put it in the oil and that will warm it up, and then once it's warm I will put the knife blade into it as well. So close that, turn it on, and then turn the temperature to the desired setting, which looks like roughly 800. And slightly more detailed than that because I've worked out what this does, and it's not 100% accurate, but that's warming up. The blade's inside, that's warming up. Now it's just a waiting game, and it takes about probably an hour and a half for it to get to the right temperature, and then we'll come back and take the knife out of the kiln and place it into the oil to cool it down. So the temperature now has reached critical. In fact, it's been at critical for the best part of 45 minutes. What that means, or why I've done it for that long, it's longer than most people do it. I've done it that long because I've got the ATP on it, which stops decarbing. Now what steel does, or what steel is crystalline structures overlaying each other. Normally the steel I use is annealed, it's soft, which makes it malleable. In a soft state, steel, the lattices are kind of relaxed and jumbled together. As you heat it up, metal expands slightly, and when you get critical temperature, the lattices actually change shape inside the steel and align. The steel is very excited at that point. It doesn't like being at that structure, and it'll only hold it because the temperature is high. Now if you take it out, cool it down slowly, it'll go back to its normal relaxed state. If however you take it out and cool it rapidly, it can't change back to that relaxed state, and it gets locked into the tight excited state, which makes the steel extremely hard. At the moment, annealed, it's around 30. When it's unannealed, or when it's hardened, it's going to be potentially up to around 65, which means if I dropped it on the concrete, it would shatter. So it gets really, really hard. Now that stuff I put on the outside of it, the ATP 641, that also expands with the heat slightly, so it keeps the coating on the metal but it can't contract like steel does when it's cooled, so it'll just fall off the outside of it. Now this canister is filled with oil, and that oil will allow the blade to cool down extremely rapidly, but not as explosively as if I just chucked it in a bucket of water. At least that's the theory. So the blade is going to be red hot at this point, ridiculously hot. So first thing I'm going to do is turn that off, turn that down, pop this open, reach in, take that, put it in there, take that, put it in there, close that, turn it back on. Now you can see in a few seconds that was doing that, the temperature of the kiln dropped. The temperature of the steel will also have dropped a little bit, but not very much, and it's going rapidly, quickly back up. So what I'm going to do next is reach in, grab the knife blade and stick it into that oil. Now you saw before that there's a bit of a flare up. That's just oil catching fire. When the blade goes in, it's so hot that the oil gets pushed away, or the steel pushes the oil away from the blade, forming a pocket, and then that can catch fire. But what I'm going to do is move the blade up and down so that it's continuously moving through warmed oil, but to the point where it should just cool down normally. Here we go. It's really hot. Now, it's not so important to cool the handle as rapidly as it is for the blade. The handle can be a little bit mucked up in its heat treat, doesn't matter if it's slightly softer, and that's all going to come out at the next step that we do anyway. But right now I'm concentrating on the blade. So, next stage. Now, because the knife isn't very good when it is so hard that it shatters like glass, one thing, you can't even sharpen it, the final step is to put it back into the kiln, this time at about 225 degrees, and let it soak in there at that temperature for 2 hours. Take it out, cool it down to room temperature, do it again, and then a third time. So in total it has 6 hours soaking, and that takes some of the stress out of the blade, makes it just a little bit softer, so that now you can sharpen it, it'll hold its edge, it won't shatter if you drop it, and all in all it's ready for the next stage of the transformation. What we've got to do is clean off all the burnt oil and things from the process of hardening and then tempering the steel, and then we need to fit the handles and the guard and various other bits and pieces. So that was the process of how I harden 01 tool steel.